Why am I so dirty? My skin is all gray. It used to be white.
Oh, I know. It must be due to the air pollution.
Really? Tell me more about it. Where are the main sources of pollutants?
Well, the first one is carbon monoxide. Naturally, it comes from the incomplete oxidation of methane, but a man-made source of this gas is the incomplete combustion of fossil fuels. For example, coal. This gas is deadly because it prevents hemoglobin in our blood from carrying oxygen by forming carboxyhemoglobin. As a result, we might all die.
What a horrible gas! Why didn't I hear of this before? I've only heard of carbon dioxide and sulfur dioxide.
Don't say the word sulfur dioxide. It is equally deadly. It is a respiratory irritant that will lead to respiratory tract infections.
Where does this thing comes from?
Naturally, it is produced by volcanoes and the decay of organic matter. But human beings, by combusting sulfur-containing coals and smelting sulfur ores, release a lot more of them.
All oxides seem deadly.
Indeed, there is this gas called oxides of nitrogen, produced naturally in electrical storms and biological processes, and manually by internal combustion in high-temperature engines. Similar to sulfur dioxide, it is a respiratory irritant which could lead to respiratory tract infections.
Okay, I'm perfectly worried about my health now. Is there any more pollutants? Please don't tell me there's more.
Unfortunately, there's two more.
Two?
Yes, two.
Oh my god.
Let me finish first. The first one is particulates, which can be anything like, for example, soot, ash, dust, and sand. Burning of fossil fuels, particularly coal and diesel, will also produce that. It can affect the respiratory system and cause lung diseases such as emphysema and bronchitis. The second one is volatile organic compounds, or VOCs. Naturally, it comes from plants, but nowadays it can also come from unburned or partially burned gasoline and other fuels, and also solvents. Some of these compounds are also carcinogenic, and some can even form toxic secondary pollutants.
I'm gonna faint.
Hey, are you guys talking about air pollutants? I hate them! However, I got some insider knowledge on how to remove them.
Really?
Yep! First, there's this method of thermal exhaust reactor. This reactor takes advantage of the heat produced due to the exhaust gases and makes the gas react again with more air to oxidize the possible carbon monoxide to carbon dioxide. So, it is 2CO plus O2 equals 2CO2. However, although carbon monoxide is converted, the product of this reaction produces another greenhouse gas, that is carbon dioxide. However, compared to the production of carbon monoxide, carbon dioxide is a lot less harmful. The thermal exhaust reactor is suitable for all types of vehicles too.
Yay, we're saved!
It's not over though. We have more!
And that is...
Lean burn engines! Using the carburetor, which is a device that blends air and fuel for internal combustion engine, we can adjust and alter the air to fuel ratio. The higher the amount of air in the air to fuel ratio, less carbon monoxide is emitted due to the fact that there are more complete combustion. However, increasing the ratio produces more oxides of nitrogen. So, to make sure that there is a healthy compromise between carbon monoxide and oxides of nitrogen emitted, a suitable ratio is needed. If the fuel mixture is too lean, then the engine will fail to combust.
I know. There's this method of catalytic converter now that you talk about engines. This is a device used for converting harmful pollutants into less harmful emissions before they leave the car's exhaust system. The hot exhaust gases are passed over a catalyst of platinum, rhodium, or palladium. They oxidize carbon monoxide and unburned volatile organic compounds, and catalyzes the reaction between carbon monoxide and nitrogen oxide. However, this reduces performance of the car due to the reduction of gas flow through the exhaust fumes, and it is also expensive to buy and replace. This also contributes to the increase in carbon dioxide in the atmosphere levels.
Okay, that was awesome! What about removing sulfur dioxide? Bet you don't know about it.
Oh, okay, you wanna bet?
Yes, of course!
Alright. You win. I don't know anything about it.
Listen to this, son. There are a few things we can do about it. First, we can just crush the coal and mix it with water. More than sulfide sink to the bottom, and clean coal can be skimmed off. It is easy and simple to do. I think doing it in a wide scale may not be very expensive too. However, it may not be efficient because some clean coal may stick with the sulfides. Another method is the fluidized bed combustion system. This means burning the coal on a bed of limestone and it removes sulfur as calcium sulfide or calcium sulfate. Many types of classes of fuel can be burned in this system, and there's a low emission of nitric oxides in combustion too. However, it can be expensive to build and maintain the facility. No, this is not over yet. The third way is scrubbing sulfur dioxide with an alkaline slurry of limestone and lime, and this is called flue gas desulfurization. The product formed in the removal can be used in other areas. For example, gypsum can be used to make plasterboard. Slurry can handle high temperatures and moistures too. However, it can be difficult to ensure all gases come into contact and react with the slurry. Another issue is that recycling the slurry incurs high operation costs. The product formed in this method can also be corrosive. It may damage the facilities and means high maintenance costs.
Cool! But I know this method that is way cooler. It is electrostatic precipitation. This method is for small particulates but not large particles, because large particles can settle under the influence of gravity in sedimentation chambers. The charged particulates are attracted to the oppositely charged electrodes. Electrodes are then shaken periodically so that the aggregated particulates can fall to the bottom of the precipitator to be removed. Advantages of this method is that it incurs low operating cost, and also it has high efficiency and able to handle large flow of gas. However, the disadvantage is that it requires a high capital cost and will not work on particulates that have a high electrical resistance. Yay, I'm so happy!
Why did everyone faint? I must faint too!